Okay. Building machine learning applications on production is hard. It's really tough, especially if you want to implement machine learning models, algorithms in real-world applications. The challenge we face is usually way more than just the modeling, way more than just the algorithm. And that's why we built PredicitonIO, an open source machine learning server. The goal is to help developers and data scientists to make the process more fun, to make it much easier for you to build reusable engines, predictive engines. So before I go into the details of what's new in PredicitonIO and introduce our newly developed software design pattern for building predictive engines, I'd like to ask one question. The question is, why do we need a machine learning server? So just want to make sure you guys are not sitting here listening to something that you don't need. Look at the space of the open source data science industry. There are a number of tools available, especially in the JVM's domain. We have Apache Spark, Hadoop, machine learning libraries. You have Apache Mahout, you have MLlib, data storage, there are a bunch of them, right? Like HBase, Cassandra's. So how many of you are actually using these tools right now? A lot of you. And how many of you are planning of implementing some of these technologies? Okay, thanks. And how many of you have heard of them? Like heard of any of these technologies? Great. So we're quite well informed in the JVM open source data science technology space, basically. And it's great because building JVM or Java open source technologies with your applications is a great way to put it onto production. But what's missing? What is missing is really something that would hold all this stuff, Spark, MLlib, Hadoop, HBase, all together to give you a production-ready development platform so that you can build reusable tools for productions, and you don't need to worry about scalability. You can spend your time better to worry about the business logics, to understand your data, and to evaluate the results to make better predictions, right? The analogy I always use is, when I'm building a web application, I don't want to build everything from scratch. I would like to have a web framework. That's what we're trying to achieve right now. And it's an early stage project, so I would love to get your feedback afterward. So let me use a very simple and classic example, in this case, to show you how you can make use of the machine learning software design pattern to do your development work better. The example is a classic recommender system. If you have read any machine learning tutorials, textbook, or materials, the first case is always a recommender system, recommending products. So you have a mobile application, and now you want to do some prediction, predict what products a user would like to buy or would like. And so you need an algorithm. And it's not difficult to find an algorithm nowadays. There are two ways you can do it. One is you download a machine learning library, Apache Mahout, or Apache Spark MLlib. They have state-of-the-art collaborative filtering algorithms, content-based algorithms, a lot of algorithms you can use right away. As a developers, we don't need to build a new model. For the rest of us, if we're data scientists, we can also build our own model, like with tools, with Hadoop, with Spark. So assuming the model is built, then we can make prediction. So this is the case that we want to look at tonight very quickly with sample code. Let's say the traditional way of building recommender system, prototyping. What do? We read data from a file. It can be a it has to be a well-defined data format file. It can be a text file. It can be a file stored in HDFS or S3. And with an existing algorithm, you can easily just load the data into the algorithm class or function, and then it will give you a predictive model. with the predictive model, what can you do? You can loop through all your users. Now you've read the data, you use an algorithm, train a model, and then with the model, you can make prediction. You load all the users into the model, and now you call a function, say, I want to recommend 5 products to each users. Done. Machine learning is so easy. Like now I have a recommended system. But what's the challenge? Getting good results. So there are a lot of tools on the market that can help you get good results. And before you know whether the result is good or not, one way you can do is do an offline test with the data set to see if the algorithm is good. But more importantly, you want to put the algorithm on production. You actually need to deploy it on production, right? So beyond prototyping, now what? You need to actually put the algorithms out, maybe as a service, so that you can respond to dynamic query. So I want to recommend 5 products to user A. I want to recommend 10 products to user B while she is in San Francisco. I want to recommend only 1 product to a user who's maybe now in New York. So it's not something you want to loop through the model and then cache all the results. So we want to deploy the engines as a service. And in the engines, you might also want to integrate a lot of business logics into it. Like, what if I'm building e-commerce applications? The products may go out of inventory, and I don't want to include the products that is no longer available in my recommended results, right? And of course, for all of us here, we know how to build this kind of code. But the question is, where should I put the code? Like, should I build my own infrastructure for things like, oh, new data comes in, I need to rebuild the model, and then we refresh the model with no downtime, or like, so if we have built web applications or mobile applications before, the concept of separation of concern is not new to us. Like, we want someone who take care of the data source, data loading. We want another person to take care of the algorithm, make sure it's highly accurate. And how do we make sure it's highly accurate? We want another component that do the evaluation. And sometimes you might want to swap out the evaluation component to do another evaluation. And also there's a serving component. You can add different business logics into it. And again, it might involve another team or another person in your company to do it. So we really need something that we can start off easily, but at the same time, it can scale out as we need on production. So this is what we will build with PredicitonIO easily with the new design pattern. So we provide an event server. It's a server that you can collect all kind of data. And there's engines underneath the hosting at the same time with the server, event server. So you store all your events, or you stream all your events into the event server. And then you can have different engines, like recommendation engines, classification engines, user churn prediction engines, things like that. You can build multiple engines under the event server. So your mobile application will send data to the event server, and you deploy an event server. In real time, the mobile application can send query to this event web service, engine web service, with REST API or with one of our many SDKs. And then you can retrieve prediction results by calling the engine's service as well. This is the ideal model we want to build. And this is much more beautiful than like just a three lines of code building it on prototype, right? So let's talk about the event server first, because it's simple, before we jump into the amazing thing like how we can actually build an engine. Event server is something come out like within the box of PredicitonIO. So you install PredicitonIO, there's an event server. The way you launch it is just type PIO event server, and then you can collect data into it just by, it's just very similar to the way you use other analytical tools like Google Analytics, Mixpanel. It's all events-based. In this case, you're sending the data. User 123 is giving the item or product 100 a rating of 5. And you can do all sorts of data integration into it. Like you can update the user attributes, you can give a description to a product and things like that. And many people would ask, hey, I already have my database. I have my MongoDB, I have my Hadoop. So what am I going to do here? I'm going to show you how we can modify where, at least not showing you how, but where you can modify the place that you will pull in data. So if you don't like the event server, you can pull data from your existing data source. But most of the time, we see cases where you would like to have a separate event store for new kind of machine learning development. So it's really up to you, open source, so it's really flexible. Now here we come to the fun part. I talk about separation of concern. I talk about a new kind of software design pattern where you can do something like MVC for machine learning. And this is exactly where we'll use it. We'll use this kind of new technologies to build an engine. So we invent a new name called DASE, DASE. Sounds much better than MVC. MVC, you can't pronounce it, but DASE is a name, right? So everyone can remember the name DASE. So DASE stand for very simple components. D, data source, data preparation. This is where you pull data into an engine. And this is where you do data cleansing so that the data format is suitable for the algorithms that you're going to use. A obviously stands for algorithms or algorithm. Depends if you're building one algorithm in this engine, or a lot of data scientists would like to combine multiple algorithms, or they want to evaluate different algorithms to see which one works better. So this is the great framework for you to work with more than one person, or if you're just trying to test out of-the-box algorithms. S is serving. This is where you put the real-time business logics. Evaluator is where you put the evaluation code. So now let's take a look at the architecture in more details. One thing that you can do is, one of the many functions of an engine is you want to train a model and deploy it as a service. Another important function of an engine is it will respond to user query and return predicted results. And of course, evaluation. But we're not going to go through talk about evaluation today. Just focus on the first two, okay? This is how it would look like when you train a model with your engine built on top of PredicitonIO platform. The event server you'll pull data from the event server from your engine with the data source component, which is a class. Like if you're familiar with the MVC of web development, every component is basically an independent class where you can swap in and swap out. And data preparator and algorithms. So data source take the data from event server, return a training data component, objects, and it will automatically be passed to the data preparator. Data preparator take it, send, and then do some processing, and send the final prepared data to all the algorithm class that you have prepared. And the models will be built, and they will be stored and be persistent in memory in a distributed cluster. So if you're planning to play with Spark, if you're doing Spark, you understand that setting up a cluster and then you can have the data handled by Spark. It might be in memory, it might be stored in the disk space, it's automatically handled by Spark. So if you build the model with the RDD format, then your model would be loaded in a cluster. It can be handled in memory or it can be in disk space. So it's automatically handled by Spark, basically. The great thing is you don't need to write all this stuff by yourself if you're using the platform. Now, actual code, very quickly, three main classes that you will look at. So everything I'm talking about is open source, so you can go to the GitHub and look at the template, engine template, with all the source codes there. I'm just trying to give a high-level view of the classes here. So data source class comes with read training function. This is where PIO train will be called. So when you want to train a model, you run a command line called PIO train. It will trigger the read training of data source, and you do all kind of fancy stuff. Not so fancy, actually, you just read data from the event server. But if you have other data source, like streaming data, email campaign data, MailChimps, you can pull all the data in to your engines at this class. And when the training data object is returned, it will trigger the prepare function of preparator. So here you can do all the data preparation, data cleansing. To me, I think why is it useful is because a lot of times we want to do different type of data cleansings. Like when I was attending the KDD competitions or things like that, when I'm trying out different algorithms, I always forget the part, okay, in this iteration, am I using this kind of cleansing method, or in that iteration, am I using another kind? So having a structure like that will make it much easier for you to manage the different components. And so return prepared data to all the algorithm class that you have defined to the train function of algorithm. And this is where you would run the MLlib or Apache Mahout or your secret algorithms. Basically, based on the prepared data, now you can train the data, prepare the model. And when you return the model will be stored automatically. So later on, the system will retrieve it to respond to prediction query. So now you have an engine, you can read data, you have an algorithm in it, you train the model, the engine is running as a service on production, and in a really scalable way. The next thing you want to define in your engine source code would be, how do you respond to dynamic query? The beautiful visual graph would be like this. The mobile application send a query that's like, for this user ID, give me 5 products. So that's the query. The query will trigger the algorithm class again, but this time another function. And the model that you have built will be loaded up automatically and make a prediction and return predicted results to the serving layer. Serving layer will be able to return the JSON format or JSON data in JSON format back to your mobile application. This is how you make prediction and retrieve prediction results in real time. And of course, we support more than one algorithms. So this is the design that we propose what modern machine learning engine development should look like. The code is simple. Let's say in your case, as I mentioned, we're building a recommender system. So the query format is user ID, and number of products that we want to recommend. But if you're building other type of machine learning tasks like classifications or regressions, you might have different types of query input. But let's just take this example. The way that you define this query is define a class, define a variable in it, define another variable in it, like user and the number of products, and make it serializable. By the way, what programming language I'm using? Scala, right. You'll get a t-shirt, I think, later on. So, good answer and correct answer. So, PredicitonIO is built on Scala right now. We support Java, we support Scala language. Scala is a beautiful JVM language, by the way. We have planned to support other programming languages. So it depends on your usage. If you're just using the engine template as is, you don't need to touch the source code. But we also give you the flexibility to customize the code like in Scala or in Java. So the same way we define a predicted result class, So the predicted results would be a list of items. So the way we define a class is basically an array of items and the score that we predict. So now you have already defined the input and output format of an engine. The platform will automatically convert the JSON data input into the class and create an object. And same-wise, for the returned result, it will automatically convert the objects to a JSON format and return to your mobile app or your website. So it's quite simple here. The two classes that you touch is algorithm and is predict function. Now it's not the train function. Train function, you use it during for model training. But for responding to user query, you use the predict function of algorithms. So your mobile application send a query, the platform will pass it to predict along with the model that you have built previously. It will load it up from Spark, Custer automatically to your function. So you can perform all kind of fancy processing. Most likely you will just call a predict function to get like 5 products. And all algorithms that you have defined it will pass the predicted results as a sequence or as a list of, basically a list, to serve of serving class. This is where you would like to combine the predicted results, or you would want to do any kind of real-time processing of the predicted results before you return it to the mobile application. So the engine itself is defined by a factory. So it defines the name of the data source, preparator, algorithm, and serving. So the cheating here is we called it DASE, but D actually has 2 components, data preparator, data source, and data preparator. But if you can come up with a better name for this design pattern, let us know, because we're always open for new names. So this is PredicitonIO. I just want to introduce the high level of way of building more reusable engines, because I believe that it's time for companies or developers like us to move beyond algorithms or just algorithm modeling, but actually apply algorithms on production. And when you want to build something on production, specific business logics, data source, distributed service, scalability is really important. And that's why we spend a lot of time developing this architecture, and it has been tested and used by hundreds of companies with a quite healthy contributors communities. So hopefully it's useful. And one bonus point of using this platform is it's built on top of the latest open source technology. So one command line of installation of PredicitonIO, you get the whole stack of Apache Spark, HBase for data storage, and the MLlib algorithm libraries. But of course, you can incorporate other algorithm libraries into it. So if you're starting out new, it's a great start. And the one-line command is developed by our coworker David, who is like at the back there, having a beer. So it's a new, young community. Feedback is really welcome. So run the command line, install PredicitonIO is what you're going to do later if you want to try it. Launch an event server with one command. Build an engine. You don't need to build an engine from scratch. You can download an engine template, like recommendation, similar product discovery. You can download them and just build it, train the model, and deploy it. If you want to update the model with new data, you just need to run the train and deploy it again. Everything will be taken care of automatically. So this is the architecture we love and we envision more and more companies will be using. You're not talking about one mobile application, but maybe your mobile application, your website, your email campaign. We have media company using it for multiple outlets, like different type of portals, all sending data into one event server. Because the great way is you aggregate all the data in the event server, so you can build different engines on it. Recommendation is just the beginning, but there are a lot of things we would love to do, like classification of, or lead score prediction and things like that. So on one single platform, your data source code can be reusable. People can build on top of it together as code that reusable and scalable. That's what we provide. And as a next step, everything, again, is on GitHub. And one thing I asked for is, if you have any feedback, let us know on our Google group, because we have been building it for 1.5 years. It's still very early. So contribution, if you want to contribute to any part of it, we really welcome contributors. We have 100 of contributors around the world right now, but we really don't have enough contributors on this project. So your participation is really welcomed. Thank you. Any questions? Very good question. So the question is about now the model requires the mobile app to send a query to the engines and retrieve prediction results. But how about cases where we just want to push the message to the mobile application? This is something we haven't developed yet, but we do have use case of push notification with one of the largest media companies. So basically, they want to push a message to users every day at certain different times. One way you can do is do a call like every hour, every half hour to the engines. The great thing about it is the call is really, like the framework itself is really lightweight, and you can add logics here to check, okay, it's not the right time to pull, so just return nothing, instead of calling the model every time. So it's an intermediate solution, not the perfect one, but hopefully it solves your problem. Another questions? Thanks. Great questions. So the question is, what's the performance? We're not good in terms of, we didn't do any performance improvement, but we're great because we built on top of the latest technology. So our performance is just as good as Apache Spark, just as good as HBase, just as good as the latest lightweight framework responding to REST API. So if you're building on top of the architecture, you can't beat the performance of Apache Spark. But I guess that's already the latest performance that you can get in terms of the JVM processing framework. Sorry? What kind of data size we're using? So it's an open source product. We don't host your data. I think that's one thing we want to, I want to clarify as well. So you install PredicitonIO on premises, or you can launch a cloud service like AWS, and you can have a private cloud of PredicitonIO installation cluster. And you import your own data into PredicitonIO. So it's really up to you. But related to the performance question, we are as fast as Spark. We are as scalable as HBase. So we have companies using it for like 15 nodes with no problem. So that's how scalable it is. Thank you. Any other questions?
How difficult do you see fitting other algorithms?
Very, very easy. So we have, technically speaking, we have two types of algorithms that we can support. One is local algorithm. Any JVM Java algorithms, or even our portable to Java algorithm, we can support with that interface. Another type of algorithms we support is anything that read RDD, return RDD, basically the Spark standard, you can integrate in it. We have like students working on the project for fun, and they integrate the graph algorithm, GraphX algorithm into the framework within a few days. So it's not extremely difficult, but if you need any support, we're happy to help as well. So I guess I should reserve the time for another great speaker, and I'll pass the time to you to introduce the speaker. Thank you.
Thank you, Simon.